Hello friends, through this video lecture I would like to explain how can we determine the wavelength of the mercury spectrum. For that we have a mercury vapor lamp and spectrometer along with the spectrometer grating. So spectrometer have collimator here, and through this opening we are going to allow the light. We can close this by using this shutter, and by adjusting this one can fix the slit width. We have a Vernier table here, we can rotate, and over that Vernier table we have a grating table with a grating stand. We can also rotate that also. Here we have the telescope. So here we have a telescope which will receive the light beams which is coming through the collimator. Before starting this experiment, we have to allow the spectrometer in the normal incident position. For that, what I am going to do means I am going to focus the long distance object through this telescope. Now I am rotating this screw, and I am getting a clear image of the long distance object which is available in my lab. Now you can see a switchboard which I have focused in this telescope. So after getting the clear image of the object which is quite far as, I am not going to rotate this screw furthermore.
Okay, sir.
Now the collimator and the telescope are placed exactly in the straight line. So one can see the slit image in this telescope. You can see the image of slit which I have focused through, using this telescope. It is actually blurred. So what I am going to do means I am going to get a clear image by adjusting the screw which is available in the collimator. Now you can see the sharp image of the slit. Now I am going to rotate the Vernier table. Vernier table have actually, you can see the readings here, you can see the scales here. This is actually the Vernier scale, 30 divisions are available, and this is actually the main scale where the degree is, it is in degree. Whenever I see the slit there in the telescope, we are supposed to overlap the vertical cross line on the image, and then we have to take reading or we have to adjust this scale. Now we got a direct slit image on this telescope, and I have placed the vertical cross line on the telescope, on the slit. Now I am going to rotate this Vernier table. One can rotate this Vernier table and can make adjustment on this scale. Now what I am going to do means I am going to place the Vernier scale 0 to the main scale 0. Now I have placed the Vernier scale 0 exactly coincidence with the Vernier scale 0 on the left side of me. This is the scale available in the right hand side. Left side we have already done the coincidence of Vernier scale 0 with the main scale 0. Right hand side automatically the Vernier scale 0 coincidence with the main scale 180 degree, which means that there is a 180 degree difference between the left side scale and the right side scale.
Yes.
Now I am going to place this grating. I have placed the grating in the grating stand, and I am going to rotate this telescope to my right hand side by 90 degree. If I rotate here in this left side scale, the coincidence gets changed, and I am just rotating the telescope. Now the main scale 0 coincidence with the Vernier scale 0 coincidence with the main scale 90 degree, which means that I have rotated the telescope by 90 degree. And after rotating this telescope, you have to get a reflected image in this telescope by rotating this grating table. I am going to rotate the grating table in a clockwise direction, and I am going to get the reflected beam. So now I started to rotate the grating table in the clockwise direction. I am getting some blurred image, blurred colored slit, and I am rotating, still rotating, still rotating, still rotating. Yes. At this position, I am getting the reflected image of the slit, which is in white. Now what I am going to do means I am going to rotate this Vernier table, not this grating table, this Vernier table by 45 degree in an anti-clockwise direction. Already here the Vernier scale 0 coincidence with the main scale 90 degree. If I rotate this Vernier table in an anti-clockwise direction means the Vernier scale 0 have to be coincidence with the main scale 45 degree. Yes, I have done. And now I have done all the preliminary adjustment. I can bring the telescope to its original position, that is straight to this collimator, and now this grating is in the normal incident mode. So the telescope is here, and you can rotate this telescope to the right hand side slowly, and here I am getting some colored slit, that is the diffracted beam. Now you can see the violet color, and if I rotate the telescope further in the sense, one can see blue color and other VIBGYOR. I have rotated the telescope further, so I can see the green, yellow and other colors. Now what I am going to do means I am going to place the vertical cross wire available there in the telescope on every color, and I am going to note down the reading both in the left as well as in the right side scale. Similarly, you can get the diffracted beam by rotating the telescope to the left hand side, and there also you can place the vertical cross wire on every colored slit, and you can take reading both the left side scale as well as the right side scale. So the slit will be like this, and your vertical cross line will be like this. Whenever you are you have to take the reading for a particular color, the vertical cross line should be like this. And I have drawn the diagram of the scale which is available there in the spectrometer. This is actually the main scale. The main scale will be like this, and as I said earlier, the Vernier scale have 30 divisions, so it is like this. So after placing the vertical cross wire on the particular color, you can take the reading. How to take the reading? Let us find where the first find the zero of this Vernier scale. Find the position of zero of this Vernier scale on the main scale. Assume that I am going to draw a dotted line straight to Vernier scale from this zero of Vernier scale, 0 to the main scale, and this is 230, this is 231 degree, and this is 232 degree. If I draw a straight line from Vernier scale 0 to main scale, means it is exactly between the 231 degree and 231 degree 30 minute. If you are getting a position like this, means your main scale reading is 230 degree, and your main scale reading, this is actually main scale reading. Then you have to note down the Vernier scale coincidence. Vernier scale have 30 divisions. Find which Vernier scale division make a straight line with main scale reading. See this line. So this line make a straight line with the main scale reading. So I am going to count. This is 1, 2, 3. So third line of Vernier scale gets coincidence with the main scale reading. If so, means your Vernier scale coincidence is 3. So how I found the main scale reading? To find the main scale reading, I have to find the position of Vernier scale 0 on the main scale. To find that position, I am going to draw an imaginary line from Vernier scale 0 to main scale, and it gets intersects on the main scale between 231 degree and 231 degree 30 minute. This is actually 30 minute. If so, means you can write down the main scale reading as 231 degree. I'm sorry, earlier I have written 230 degree. It is actually 231 degree. Now you have to find the Vernier scale coincidence after taking the main scale reading. Vernier scale have 30 divisions. Out of that 30 lines, any one of the line gets coincidence with the main scale reading. Now look at this fourth line, third line actually third line. This third line gets coincidence with the main scale. If so, means 3 is the Vernier scale coincidence. We have to take reading on the left side, as well as you have a right side also. You have another scale, you have to take reading there also. So whenever you are supposed to take a reading on the spectrometer, you have to note down both left side scale and also the right side scale reading. Okay. In that way you can take reading both by rotating the telescope to the left hand side as well as the right hand side. So this is the tabulation to note down the reading. Here we have specified the colors, and whatever the reading you are taking in the left side scale, it was noted on the tabular column like Vernier A, and in the right side scale it was noted in the name Vernier B. This is here you can note down the reading when the telescope is in the left side, and here you can note down the reading when the telescope is in the right side. Now using that tabular column, you can one can calculate the diffracted angle. If you know the diffracted angle and the number of lines available in this grating, one can find the wavelength of any spectrum by using the formula lambda is equal to sin theta by n, capital N, into small n. Here theta is nothing but a diffracted angle of diffraction, and capital N is nothing but the number of lines available there in the grating, and small n is nothing but the order of the fringes. What I have shown, that is the first order fringe. If you rotate the telescope further, you will get one more set of color light, that is the second order spectrum.
Yes, sir.
Thank you.